Hello guys, I hope you're doing well. This is Mac, your instructor IAS, and welcome to lecture number 2 on scalars and vectors. Guys, today we'll be discussing about how to resolve the vectors. In your syllabus, we have to resolve the vectors of right angles, and sometimes it gets very challenging. So you need to actually understand how are we going to resolve the vectors. There can be many situations where you need the vertical and the horizontal component, and there can be a lot of different ways you can get the angles. Most of the time the angles will be given to you, and how will be this resolution be working. So first of all, we're going to be discussing a very simple basic understanding of what this resolutions of vector means, and why do we need that, and what can be done in order to actually resolve the vectors, and where in which case scenarios they are very useful. So first of all, you need to realize that these resolution of vectors actually comes up in your exams a lot, and they're basically part of all the questions. You are given with two things. Let's say you are given with an angle, and you are given with a velocity in the first case scenario. If an object is moving with a velocity of 15 meters per second at an angle of 25 degrees. Now, what resolution of vector actually means? Resolutions means to break it in vertical and horizontal components. Why do we need that? If something is moving at an angle of 25 degrees, that means it's moving up and it's moving to the right as well. So in a lot of scenarios, we only have to consider the velocity with which it is moving up. In a lot of scenarios, we have to just consider the velocity in which it is moving to the right. Similarly, we have to resolve a lot of forces, a lot of things, so that we can get to certain answers. So this is basically what resolutions of vectors actually means. If let's suppose something is moving with 15 meters per second at an angle of 25 degrees, and the examiner asks you to resolve it. So there are going to be always two components. First component is basically the vertical component, and the second one is basically the horizontal component. If I want to have the vertical component, you can realize that it's always going to be 90 degrees. This is the hypotenuse, this is the vertical component, and this is the angle that is given in the question. So that vertical component is going to be basically the opposite of the angle. Let me just get back to IGCSE mathematics. We discussed three angle finding techniques or ratios of trigonometry. Sine is equals to opposite over hypotenuse. Cos is equals to adjacent over hypotenuse. Tan is equals to opposite over adjacent. In your AS level, you are not required to use the sine or cosine rule, since they are not part of our syllabus, and that's a very specific point. A lot of students do questions with them and get the right answers, but they're not allowed. So you need to make sure that you use these ratios of trigonometry and you use the scale diagrams only. Well, moving on. This angle is given, I've got the hypotenuse, I need the vertical. So I would use sine theta is equals to opposite is basically the vertical, and hypotenuse is 15. So I can just get 15 sine 25. That is going to be the vertical component. I'm just going to write vertical component as we see. Similarly, if I need the horizontal component, so I can do is use cos theta. So cos 25 is equals to adjacent is basically the horizontal component, and hypotenuse is 15. So my horizontal component would be 15 cos 25. This would be my vertical component, and this 15 cos 25 would actually be my horizontal component. Now there's one point that is very much important to be learned over here. Component that is in front of the angle is always the component of sine, and the component that is basically with the angle is the component of cos. So the component that is in front of the angle is the sine component, and the component that is with the angle is the cos component. Similarly, if you have this angle 15 degrees given, and now you need the vertical and horizontal component of this force. So let me just get to the second part. You'll make a straight line and then you'll make this line. You would actually realize, okay, so the angle is given as 15. This is the vertical component and this is the horizontal component. A lot of students make this mistake to actually remember this in a way that, okay, sir, all the vertical components will be sine. That's not the case. No, that's so wrong. You need to actually realize that the component that is in front of the angle is going to be the sine component, and the component that is with the angle is going to be the cos component. Second time, I'm again going to be using trigonometry in order to solve this. So for the horizontal component, sine theta is equals to opposite, that in this case is the horizontal component, over hypotenuse, that's 20. So 20 sine 15 over here will basically be the horizontal component because it is opposite of the angle. So you can write this key point as well. All the components opposite of angle are always the sine ones, and all the components with the angle are always the cos ones. So again, cos 15 is equals to, now I've got the adjacent, ka, adjacent over hypotenuse. Adjacent will be the vertical component and hypotenuse will be 20. So I can just multiply 20 by cos 15 to get the vertical component. So if you realize, in the initial one, the vertical component was the cos one, and in this case, the horizontal component is the, sorry, in the initial one, the horizontal component was the cos one. In this case, horizontal component is the sine one. So it is not necessary that all the verticals will be sine, all the horizontals will be cos. It's not the case. But you actually have to be able to resolve these vectors. This resolution is very much important when it comes to the questions, since we need it in the free body diagrams and a lot of things, and we also need it in calculation for the projectile. That's why I'm putting a great emphasis on this. Make sure that you understand this. Moving on. All right. Now let's assume you have got these two angles given, and you are required to resolve this. This time I'm not going to be using direct trigonometry. I'm going to be using trigonometry, but I'm not going to be like putting it. I'm just going to be asking you guys. So this is basically the, what do we call it? Vertical component, and this is actually the horizontal component. So in this case, horizontal component will be, since horizontal component is like opposite of the angle, so it will be the sine component. So I can just write 120 sine 60. So a final form, we can use hypotenuse sine angle. This is a general way to write hypotenuse sine angle for component in front of the angle, in front, or you can say opposite of the angle. This is just a general way to remember it. Then this HIP is hypotenuse. Cos theta is for component with the angle. Now I'm going to be putting this into practice. Now since I need the vertical component now, so vertical component is with the angle, so vertical component will be equal to hypotenuse cos, and angle is 60. I hope this makes sense. Similarly over here, I've got this component that's going to be the horizontal one, and this component that's going to be the vertical one. So if you realize I've got the angle over here, so I can just use the, for the this horizontal component, since it's with the angle, so with the angle we know that hypotenuse cos theta, so hypotenuse is going to be 50 cos 50, that will be the horizontal component, and for the vertical component, again, I can use hypotenuse sine theta. That will be the vertical component. So this is how you are going to be basically resolving vectors when it comes to right angle vectors. In our syllabus, we are not required to use cosine and sine rule. They are not necessary for our specifications of IAS. Although a lot of questions can be solved, but they are not allowed to be solved in that manner. In next class, we'll be doing some free body diagrams and vector resolutions from the scale diagrams and tip to tail methods, so that your concepts are going to be a little bit matured. These questions need a lot of practice. Let's solve one MCQ before ending the lesson. A tennis ball is moving through the air. The diagram shows the horizontal and vertical component of the velocity. Which of the following expression gives the magnitude of the velocity in meters per second? Alright guys, so magnitude of the velocity is this. Not all the things are required to be used. Okay, this is basically the hypotenuse. So if I were to find the velocity, I can find it in two ways. I can use velocity equals, since it's the hypotenuse, I can first of all use the Pythagoras theorem, that's not used. And I can use sine theta. Sine theta is equals to opposite over hypotenuse. That's basically 5.5 over velocity, because sine is equals to opposite over hypotenuse. So if velocity is to be found, I can use 5.5 divided by sine 22.6. Well, that's the first one. But if I were to use the cos one, I can't use the cos one since all of them are written in sine. So that's why I used my mind. I made the concept of sine in front of me, and then I rearranged that and I got the velocity. This is the hypotenuse, this is the opposite, this is the angle. This is just given to confuse you guys. You need to actually understand that. There's one more way to do it. You can use the Pythagoras theorem to get the value and then do one by one in the calculator. Whatever value is same as the value you got by the Pythagoras, you can actually say that's correct as well. So that again you will get C as an answer. These are two ways to do this MCQ. Well, moving on, in the next lecture, we'll be doing a lot of past papers, tip to tail methods, the one we did in the previous lesson. Make sure that you're very good in the first two lectures of vectors, so that we can actually understand what is going on in the questions. So free body diagrams and questions regarding that. See you in the next lecture. Take care, guys. Since you're enjoying the lectures, just wanted to inform you that there are premium batches going on. That is a direct way to get A's and A stars. It has got some exclusive content that is not generally available neither on the website nor on the YouTube. So you can join the batch to get your grade.